Time already moves differently. The real science behind time travel. Close your eyes. Let the world slow down. Now, imagine this. Time is not a river that flows evenly. It bends, it stretches, it speeds up and slows down depending on where you are and how fast you're moving. This isn't science fiction. This is your universe. Welcome to the quiet world of time travel, not as a dream, but as a science. Time isn't absolute. In 1905, Albert Einstein changed everything. He proposed that time and space are linked, part of a fabric called space-time. When you move faster, time moves slower for you. When you're near strong gravity, time also slows. This isn't a theory anymore. It's been proven. Time is not fixed. It's flexible. The Haffel-Keating experiment proved it. In 1971, scientists Joseph Haffel and Richard Keating boarded commercial airliners with atomic clocks, some flying east, some west, while a reference clock stayed on Earth. After their flights, the clocks showed different times, not by much, just a few billionths of a second. But it matched Einstein's predictions perfectly. Time had moved at different speeds, depending on direction, speed, and gravity. This experiment has been repeated and verified around the world. Time travel in the tiniest way is already real. Moons from the sky experience it every moment. High above you, cosmic rays strike the upper atmosphere, creating particles called muons. They should decay in microseconds, far too quickly to reach the ground, but they do. Why? Because they're moving so fast that time slows down for them. In their own frame, only moments pass. For us, enough time for them to arrive. We are touched by particles that experience time differently, observed by countless physicists. Time dilation keeps the sky connected to the Earth. GPS satellites depend on time travel. You use GPS to find a coffee shop, or a park, or home. But those satellites orbit high above Earth, where gravity is weaker and their speed is high. Both effects make time move faster for them than for us on the ground. Engineers must constantly adjust for this. Without these corrections, GPS would drift 10 kilometers off every day. Your phone works because we understand time travel. This is not theory, it's operational. It's proof you carry time distortion in your pocket. What is time dilation really? Imagine two people, one on Earth, one in a spaceship near the speed of light. The astronaut travels for what feels like days, but when they return, years have passed on Earth. This is called time dilation. It means you can move forward in time by going fast enough. One day we might send astronauts who return to find Earth decades older. Time machines? Not quite. But time can be stepped over. Closed time-like curves, the loops of possibility. Some solutions to Einstein's equations allow for closed time-like curves. These are loops in space-time that let objects, or information, return to earlier points in time. They are allowed by the math, but we don't yet know if they're possible physically. They raise all the paradoxes. Could you meet your past self? Could you change history? So far, nature hasn't answered. Mathematically valid, physically unproven, but not ruled out. Quantum simulations have tested time loops. In 2015, researchers simulated a qubit, the quantum version of a computer bit, traveling through a closed time-like curve. It interacted with a past version of itself, and surprisingly, the paradox was avoided. The system resolved itself cleanly with consistent behavior. No grandfather paradox, no broken logic, just quiet coherence. It's a simulation, not a machine, but the rules behaved. Electromagnetic time mirrors reverse waves. In 2023 and again in 2025, physicists used metamaterials to reverse electromagnetic waves, making them propagate backward in time. These aren't machines for people, but they show that certain physical systems can echo time's reverse flow. If waves can move backward, could information? Why can't we go backward in time yet? The laws of physics often work both forward and backward, but in our world, time has direction from past to future. Some believe entropy, the tendency of systems to become more disordered, is the reason. Others think it's our perception. Either way, something breaks the symmetry. Something makes before different from after. Time is a dimension, but we only move one way. In space, you can move left or right, up or down, forward or back, but in time, we move forward, always. Why? No one truly knows, but some physicists suspect that time itself is a construct shaped by observation and entanglement. The arrow of time might not point one way, we just experience it that way. Your body is already time traveling. You, yes, you, are already in motion through time. Your feet are slightly closer to Earth's center than your head, so gravity affects them more. Time ticks fractionally slower at your feet than at your head. You are a tiny time traveler, a soft, split-second machine. Time, it turns out, is not rigid. It bends near mountains. It changes with speed. It splits particles. It fuels our GPS. It lets us look back billions of years at starlight, and maybe one day it will let us look back at ourselves. Time is not a line, it's a fabric, and we are woven into it. Beyond the clock, the theories that bend time. You can feel it, the ticking of time. Seconds become minutes, minutes become hours. But deep in the world of physics, time doesn't tick. It ripples, folds, connects. Let's drift deeper into the ideas and experiments that suggest time isn't what it seems. Quantum entanglement connects particles instantly. Entangled particles share a connection across space and seemingly across time. When one is measured, the other reacts immediately, no matter the distance. Some suggest this link might also stretch across when, not just where. Einstein called it spooky action at a distance. It may also be spooky action in time, repeated in laboratories, verified by countless experiments. Strange, but true. Wormholes could bridge different points in time. Wormholes, also known as Einstein-Rosen bridges, are theoretical tunnels through space-time. If one mouth is accelerated close to light speed, time dilation occurs. When it returns, the two mouths are no longer in sync. Step through one side and exit into the past. The math checks out. We just don't know if nature allows stable ones. The Alcubierre drive proposes warping space-time. In 1994, physicist Miguel Alcubierre suggested a way to move faster than light, not through space, but by compressing it ahead and expanding it behind. Inside this warp bubble, time could behave differently. Travel far, return before you left. The theory works on paper, but it requires exotic matter, something we've never found. Delayed choice experiments blur past and present. In quantum physics, the delayed choice experiment suggests that decisions made in the present can affect how particles behaved in the past. It's not time travel in the cinematic sense, but it's deeply unsettling. It's as if reality waits for your decision to take shape. Tested by physicists like Wheeler and Zeilinger, confirmed, real. Black holes may preserve information. Once believed to destroy everything inside, new theories suggest black holes store information on their event horizons and might even release it slowly over time. This ties into holographic theory, where the universe is encoded on a two-dimensional surface. Could some version of the past be preserved on a cosmic shell, backed by Hawking, Susskind, and recent breakthroughs? No paradoxes needed. Time might not be fundamental at all. Carlo Rovelli and others propose that time isn't basic. It emerges from relationships between particles, from entanglement and statistical averages. If true, time isn't something that flows, it's something that forms, like a mirage of order. In this view, time travel isn't about movement, it's about rearrangement, theoretical physics, elegant and increasingly respected. You can see into the past by looking at the stars. When you gaze at the night sky, you're looking into history. The light from Sirius took 8.6 years to reach you. The Andromeda Galaxy, 2.5 million years. The light is fresh to your eyes, but old in age. You are, in a small way, watching the past happen now. Astronomy is built on this principle, a fact as solid as Earth beneath you. The twin paradox is real, a classic example of special relativity. If one twin travels near the speed of light and returns, they'll be younger than the twin who stayed home. It's not a story, it's physics, muons, astronauts, even GPS satellites prove it. We've already seen it, just not at human scales, yet, proven through countless tests. Time travel forward, already done. The universe may be cyclical. Some models suggest the universe expands, collapses, and expands again, like a breath. If true, every Big Bang might echo the one before. Could time reset itself? Could events return slightly different? It's not proof, but it's possibility. Interesting cosmology needs more data. Quantum retrocausality is under investigation. In certain quantum models, effects might ripple backward, subtly influencing past conditions based on future measurements. The implications? Hard to grasp, but some researchers think it could explain quantum weirdness without paradox. Reality may be less chronological than we think, still debated, but serious minds are exploring it. Some photons don't age. Light particles, photons, travel at the speed of light. For them, according to relativity, time doesn't pass. A photon born in the sun reaches your eye in 8 minutes. From its point of view, instantly, in its own strange way, light never lives in time at all. The future is unwritten, but not disconnected. The rules of quantum mechanics show that probabilities, not certainties, guide what comes next. Yet somehow, particles resolve in ways that preserve consistency. The story always makes sense, even if its pieces are scattered. Maybe that's all time is, the sorting of events into meaning. Signs and shadows. Real-world time travel mysteries. The world is full of stories. Most fade with time. Some, however, leave a trace. A photo, a film reel, a government file. Not proof, not fiction, just a whisper that maybe, just maybe, someone stepped outside the clock. Let's move gently now through the strange and the possible. The Chaplin Time Traveler. In 2010, filmmaker George Clark examined footage from the 1928 premiere of Charlie Chaplin's film The Circus. In the background, a woman appears to be speaking into a small handheld object, held like a modern cell phone. She walks alone, lips moving. There were no mobile devices then, no known technology that looked like this. It could be a hearing aid or an illusion, but some wondered, was she calling across time? The Time-Traveling Hipster, a black and white photo from 1941 taken at the reopening of South Fork Bridge in Canada, shows a man who appears out of place. He wears sunglasses and a logo-printed shirt. Some say he holds a modern camera. Around him, people wear suits and fedoras. He looks relaxed, an observer. The image is real, unedited, and it still invites questions. The Mystery of John Titor. In 2000, someone began posting on internet forums claiming to be from the year 2036. He said he was a U.S. soldier sent back in time to retrieve an IBM 5100 computer. His messages included predictions, some vague, others strangely technical. He vanished in 2001. Many believe it was a hoax. Others still study his posts, searching for patterns. The Man from Torrid. In 1954, a traveler arrived at Haneda Airport in Tokyo. He held a passport from Torrid, a country that does not exist. He insisted it was real. He pointed to it on a map, where Andorra sits. His documents appeared authentic. He was detained overnight, and by morning he was gone, along with his documents. No name, no trace, just one blank space in time. Andrew Carlson, The Wall Street Anomaly. In 2003, a man was allegedly arrested by the SEC for making 126 high-risk stock trades and profiting on every single one. He claimed he was from the year 2256, using future knowledge. The story appeared in tabloids, but no arrest record was ever confirmed, no birth certificate, no history, just a whisper in financial archives. The Philadelphia experiment, said to have occurred in 1943, this alleged U.S. Navy experiment aimed to make the USS Eldridge invisible to radar. Some witnesses claim it also briefly teleported or time-shifted. Crew members reportedly suffered confusion, insanity, or were fused with the ship's hull. The U.S. Navy denies the event entirely. There is no proof, but the rumors never stopped. Project Pegasus and time travel claims. Andrew Basiago, a former lawyer, claimed he was part of a DARPA time travel program in the 1970s called Project Pegasus. He described jump rooms, chronovisors, and meetings with future presidents. His stories are extensive and completely unverified, but detailed, imaginative, and persistent. They read like fiction or memory. The Montauk Project, linked to the Philadelphia experiment. This conspiracy centers on Montauk Air Force Station in New York. Claims include time portals, mind control, and interdimensional travel. It inspired the Stranger Things series. Documents remain classified. No physical evidence has surfaced, but the location exists, and its silence is total. The Air Marshal's Watch. During a 2008 excavation in China, archaeologists discovered a small, centuries-old sealed tomb. Inside, among the traditional artifacts, was a tiny metal object resembling a modern wristwatch. The time was frozen at 10:06. It bore the word Swiss. The tomb had been undisturbed since the Ming Dynasty. Perhaps it fell in after, perhaps not. The Sverdlovsk clock photo. A widely circulated Soviet-era photograph appears to show a young soldier with what looks like a digital wristwatch, long before such devices were common. The soldier's name is unknown. The photo's origin is debated, but the object stands out, sleek, unfamiliar, ahead of its time. It may be nothing, or it may be everything. Chrononauts in art. Some Renaissance paintings, sculptures, and tapestries show objects that resemble laptops, smartphones, or modern tools. One example, The Baptism of Christ by Arent de Gelder, features a circular object in the sky, emitting beams of light. Another, The Madonna with Saint Giovannino, shows a flying object in the sky as a man watches below. Artists paint imagination, but sometimes they paint memory. The sensation of being out of time. Many people, from ancient mystics to modern psychologists, describe experiences of time distortion, moments that stretch or collapse, déjà vu, visions of the future. Science calls some of these memory errors. Others remain unexplained, but they are real to the people who live them. Time is not only measured by clocks. Sometimes it's felt. So what do we make of these moments? They are not conclusions. They are curiosities, fragments, maybe hoaxes, maybe history, maybe a hint that someone, somewhere, once slipped sideways into a second that did not belong. And as you drift now, eyes closed, breath soft, you may wonder if someone did walk through time. Would they leave a trail, or would they pass as you do now? Gently, unseen. The weight of time, how gravity bends the clock. You are lying still, but even now time is moving differently at your head than at your feet. Not by much, just a fraction of a fraction, but it's there, because you live in a world where gravity curves time, and the deeper the gravity, the slower the clock. General relativity shows gravity and time are the same. Einstein's theory of general relativity didn't just reshape how we see gravity, it told us that gravity is the bending of space-time. The more mass something has, the more it distorts space. And with that, it also slows time. A planet doesn't pull you down, it bends the space you stand on. Time slows near massive bodies. On Earth, time moves slightly slower at sea level than on a mountain. Why? Because the gravitational pull is stronger closer to Earth's core, and the stronger the gravity, the slower the flow of time. Clocks tick faster on Everest than they do in New York. This was proven with atomic clocks. Scientists placed synchronized atomic clocks at different altitudes, on mountaintops, in aircraft, and underground. Each clock drifted at different rates, matching predictions. Gravity wasn't just affecting objects, it was bending the passage of time itself. You don't need to imagine time travel, you live inside it. Satellites adjust their time daily. GPS satellites orbit high above Earth. Up there, they experience both weaker gravity and faster motion. These two effects, one slowing time, one speeding it up, must be constantly balanced. Engineers program their clocks to stay synced with Earth-bound systems. Without correction, GPS would drift wildly, our location data would fail, planes would veer, phones would misplace us, but timekeeping keeps us grounded. Time freezes at the edge of a black hole. Imagine standing at the edge of a black hole, that invisible point of no return. From the outside, an observer would see your clock slow and then stop. Time itself appears to freeze, not from choice, from gravity so intense, space folds in on itself. From your perspective, you fall quickly. From ours, you never arrive. Light loses energy climbing out of gravity. When light escapes a strong gravitational field, it stretches. Its wavelength grows longer. Its color shifts. This is called gravitational redshift, but it's also a sign that time is different at the source. The clock there is slower. Light is not just a messenger. It carries the fingerprint of time's curve. Time passes faster on the moon. Because the moon has weaker gravity than Earth, time flows slightly faster on its surface. Not enough to notice, but measurable. On Mars, it's different again. Time stretches a little more. Each world in our solar system keeps its own tempo, its own quiet rhythm. The ISS astronauts live in time offset. The International Space Station orbits Earth at 7.66 kilometers per second. This speed slows time slightly, but because it's farther from Earth's core, where gravity is weaker, time also speeds up. The result? A subtle balance. But over time, astronauts age a tiny bit less than we do. They're not just flying through space, they're stretching time. The stronger the gravity, the deeper the time well. Physicists call this effect a gravitational potential. The deeper you go into a gravity well, like near a neutron star or black hole, the slower your time runs compared to someone far away. On Earth, it's barely noticeable. In space, it matters. Every step toward a massive object is a step away from normal time. Could we use gravity to build a time machine? Some theories suggest it's possible. If we could create a rotating black hole or a Tipler cylinder and loop around its intense gravity, we might return to an earlier moment, but the forces would destroy any object. The math is tantalizing. The reality remains distant. Still, the path is drawn in numbers. Wormholes might use gravity to jump between times. If one end of a wormhole is placed in a strong gravitational field and the other isn't, time between the ends could become out of sync. The result? A bridge that not only spans distance, but time. No laws of physics rule this out, only engineering and imagination. You are aging faster than the Earth's core. Right now, your body is aging more quickly than the molten iron at the center of the planet. That's not science fiction, That's gravitational time dilation, and it reminds us, even standing still, we are always in motion through time, uneven, flowing, bending around mass. Time is not flat, it's a hill, and every moment we're walking its curves. Code, qubits, and loops, time travel in the lab. The room is silent. A laser flickers, a crystal glows, a qubit spins, not up, not down, but both, and in that suspended, shimmering moment, time is no longer just forward. It's sideways, it's uncertain, it's experimental. Let's step into the labs where time is already being studied, shaped, and sometimes gently bent. Quantum computers do not obey ordinary time. Unlike traditional computers, which process bits as either 0 or 1, quantum computers use qubits. A qubit can be 0, 1, or both at once. This is called superposition, and it allows quantum computers to solve problems using multiple timelines, all in parallel. They don't just process faster, they process stranger. IBM, Google, and others are racing toward quantum supremacy. These aren't science fiction companies. They are building machines that already outperform classical computers on specific tasks, and in doing so, they're laying the groundwork for time-sensitive calculations, quantum encryption, time-correlated systems, and simulations of temporal logic. What once needed fantasy now uses silicon. Time loops are being tested in quantum simulations. In 2015, researchers created a model where a particle, a qubit, entered a closed time-like curve and interacted with its past self. The result? No paradox. The loop stabilized. The past version adjusted to maintain consistency with the future. The universe, it seems, prefers order, even in time. Quantum teleportation moves information instantly. While not moving matter, quantum teleportation transfers the state of a qubit from one particle to another, instantly, over distance. It relies on entanglement. Some call it spooky, others call it routine. But every time it happens, the rules of classical time are quietly ignored, a whisper between particles, without delay. In some experiments, time flows backward, not for people, not for clocks, but for particles. Certain systems, under extremely controlled conditions, exhibit time-reversed behavior. A photon can be made to return to its previous state. A wave can undo itself. Scientists call this time reversal symmetry. It's not a portal, but it is a mirror. Time crystals exist. In 2021, scientists created the first time crystal, a new phase of matter that changes in time without using energy. Like a pendulum that swings forever, it repeats a pattern of motion in time, not just in space. It's not time travel, but it's time behaving in loops. Simulations of space-time curvature are being built. Using light and metamaterials, researchers simulate how gravity affects time. In these experimental setups, light bends as it would near a black hole. Time is not truly distorted, but its behavior is. These models help us understand what might be possible in full-scale physics, blueprints for machines not yet built. Some theories say information can travel backward. In quantum mechanics, certain interpretations, like the two-state vector formalism, suggest events are influenced both by the past and by the future. A particle's behavior may depend on conditions ahead of it in time. This doesn't allow time travel, but it blurs direction. Causality, it seems, may be more flexible than we thought. Chronology protection may exist naturally. Physicist Stephen Hawking once proposed the chronology protection conjecture that the laws of physics prevent paradoxical time travel by default. Every attempt to create a time machine, he said, would self-destruct before breaking causality. In this view, time is defended, not by machines, but by logic. Time entanglement is under research. Beyond spatial entanglement, where particles are linked over distance, some scientists are exploring temporal entanglement, a particle affecting its future or past state through time correlation. These systems are delicate, but the concept is quietly revolutionary. Space may not be the only thing entangled. Some experiments show particles changing based on future measurements. This isn't science fiction. In certain delayed choice quantum experiments, a decision made now appears to affect how a particle behaved earlier. It's not a trick. It's not a flaw. It's simply what the math and the detectors reveal. The particle knew how it would be measured before it was. The future of time travel may begin with information. What if time travel doesn't mean sending bodies, but sending data, signals, states, corrections? As quantum computers grow, and as our understanding deepens, we may discover that traveling through time isn't about motion. It's about awareness, about transfer, about reaching into tomorrow and receiving something back. The mind's clock. How we experience time differently. Close your eyes. Have you ever noticed how time speeds up when you're joyful, or drags when you wait? How a single second can feel like forever in a moment of fear? How dreams stretch across what feels like hours, even though they last only minutes? This is time, too, but not as science measures it, as you do. Your brain does not keep perfect time. The brain doesn't have a single clock. Instead, different neural systems track durations. Some use rhythms, others use memory. Your perception of time is a construction, assembled like a story. That story shifts constantly, not because time changes, but because you do. Fear slows your time perception. In moments of danger, the brain releases adrenaline. Your senses sharpen. Your awareness widens. This makes events feel stretched. It's not that time slows, but that your brain processes more in less time. It's like turning up the resolution of reality. Childhood feels longer for a reason. When you're young, every experience is new. Novelty slows time perception. Days feel full, years feel vast. As you age and routines form, fewer new memories are created. Time feels faster because your brain compresses what it already knows. Wonder is a time stretcher. Sleep changes time's shape. During dreams, time behaves unpredictably. Events unfold in minutes or seconds that feel like hours. Some dreams cover years of imagined life. This isn't fantasy. It's how your mind weaves narrative from fragments. In dreams, you are already a time traveler. Meditation alters time awareness. In deep meditation, practitioners report time disappearing. Minutes feel like seconds or stretch endlessly. Brain scans show changes in activity related to self-awareness and sensory input. With quiet comes timelessness. In stillness, time steps aside. Memory is not stored chronologically. We imagine memory as a timeline, but the brain stores moments by emotion, importance, and association. That's why a smell can bring you instantly to childhood, or why a song feels like a year in an instant. Memory is a map, not a clock. Some people see time spatially. In a condition called time-space synesthesia, people visualize time as shapes or spatial maps. A year might appear as a circle, a week as a ribbon. They see where in time they are, like a dot on a calendar inside their mind. For some, time is visual, not abstract. Brain injury can warp time. People with damage to specific brain regions, such as the insular cortex or basal ganglia, often lose track of duration. Minutes feel like hours. Hours vanish in moments. This shows that time isn't external, it's built within, and when the builder is injured, time itself falters. Astronauts experience time differently. On the International Space Station, astronauts orbit Earth every 90 minutes. They see 16 sunrises and sunsets in a single day. This, combined with microgravity and schedule shifts, causes space lag, a confusion of temporal rhythm. Even their bodies lose track of when they are. Loneliness distorts the clock. Isolation has a profound effect on time perception. In studies, people placed in silent environments or alone for long durations often misjudge how long they've been there. Some report time stopping, others say it rushes unpredictably. Time needs other people to feel steady. Flow states erase time entirely. When you're deeply immersed in music, art, sport, or work, time seems to vanish. Hours pass like minutes. This is called flow. In this state, your brain releases dopamine and quiets the inner narrator. Time is no longer tracked. It's lived. You are not watching time. You are inside it. The future lives in your imagination. When you think about tomorrow, your brain activates many of the same areas it uses to remember the past. Planning, dreaming, even worry, all are time travel acts. You project yourself forward, running simulations. You are your own time machine. So while machines may chase time with wires and algorithms, you already carry a clock more fluid and more beautiful. One that loops, forgets, pauses, leaps, and rewinds in your breath, in your memories, in your dreams. Eternal circles, how ancient cultures understood time. Listen closely. Before there were clocks, there were shadows. Before there were seconds, there were seasons. The sun rose and it set. The stars circled overhead. The harvest came, and so did the flood. And in these rhythms, ancient people found time. But to them, time was not always a straight road. Sometimes it was a circle. The Mayans tracked time through cycles. The Mayan civilization built one of the most sophisticated timekeeping systems in ancient history. They used multiple calendars at once, one for sacred rituals, one for solar days, and one for long cycles of history. To them, time repeated. Events were part of a greater cycle: birth, death, renewal. What was would be again. The Hindu concept of time is vast. In Hindu cosmology, time is divided into yugas, vast cosmic ages, each lasting millions of years. Entire universes rise and fall across these epochs. The current age, Kali Yuga, is considered a time of decline, but even this will pass. Time here is not linear. It is endless, like the breath of the divine. Ancient Egyptians tied time to the stars. For the Egyptians, time was regulated by the heliacal rising of Sirius, the star whose reappearance predicted the flooding of the Nile. Their calendar aligned with celestial rhythms. Life itself was a reflection of the sky. In tombs and temples, time was carved into stone, eternal, cyclical, unbroken. The Greeks had two words for time. In classical Greek thought, chronos represented measured time, the ticking of seconds and hours. But kairos meant the opportune moment, a kind of sacred timing when action was right. One was mechanical, the other magical. To live wisely meant knowing both. Aboriginal Australians walk through dream time. In Aboriginal belief systems, the dreaming is a timeless realm, not the past, not the future, but always present. It holds the ancestral stories of the land, the spirits, and the people. When they tell a story, they don't just remember it, they enter it. Time is not behind them, it's beside them. Stonehenge marks more than the solstice. Built over 5,000 years ago, Stonehenge aligns with the midsummer sunrise, but its geometry also maps lunar cycles, eclipses, and the rhythm of the heavens. It is not just a monument, it is a calendar in stone, a tool for measuring the flow of time itself, an ancient observatory, and perhaps a temple to eternity. The Aztecs believed in repeating worlds. Aztec cosmology described multiple ages, called suns, each ending in catastrophe and rebirth. They believed we now live in the fifth sun. The previous worlds were destroyed by wind, fire, jaguars, and floods. They saw time not as endless progress, but as echo. The Incas built with time in mind. Inca temples and cities were aligned with solstices, equinoxes, and star paths. At Machu Picchu, windows frame the sunrise during specific days of the year. These alignments were not accidents. They were invitations to observe time, not just as light, but as presence. Sunlight became ceremony. Chinese philosophy viewed time as balance. In Taoism, time is part of the Tao, the natural flow. It is not fought, but followed. Seasons are honored. Change is expected. The I Ching, or Book of Changes, reflects this, offering guidance not by predicting events, but by harmonizing with cycles. In this view, wisdom is knowing where you are in the rhythm. Norse mythology speaks of Ragnarok and rebirth. The Norse did not fear the end of time, they expected it. Ragnarok, the final battle, would destroy the gods and the world. But from that destruction, a new world would rise, life would return, time would begin again. Even the end was a new beginning. In medieval Europe, time became linear. With the rise of Christianity, time began to be seen as a journey from creation to judgment. The idea of history as a straight path toward a divine end reshaped Western thought. Clocks followed, calendars became sacred, and eternity was placed at the end. The straight line replaced the circle. Ancient structures echo time's design, from the pyramids of Egypt to the observatories of Chaco Canyon, from the sundials of Rome to the moondials of China. Ancient humans built with time in mind. They did not simply record it, they lived it, marked by shadow, star, and stone. Their lives were woven into the rhythm of time. So as we gaze through telescopes and equations, chasing time across dimensions, we can still hear the echo of firelight, chanting, carving, and counting. The ancients may not have had qubits or atomic clocks, but they knew time just as deeply. The edge of the clock, paradoxes, possibilities, and the arrow of time. You are here, in this moment, and now that moment is gone. Another one arrives, and then passes. Time keeps flowing, second by second, never stopping, never turning back. But why? Why forward? Why at all? Let's walk softly now through the final mysteries of time. The grandfather paradox waits in every loop. If you travel back in time and prevent your grandfather from meeting your grandmother, then you were never born. But if you were never born, who went back in time? This is the grandfather paradox, the classic contradiction of backward time travel, a loop with no solution, or perhaps a clue that time doesn't allow such loops at all. The bootstrap paradox is even stranger. What if you go back in time and give Shakespeare a copy of Hamlet, and he publishes it as his own? Who really wrote it? This is the bootstrap paradox. When something exists without origin, looping through time endlessly, a song, a machine, a book, it becomes its own cause. Time becomes its own author. Entropy defines the arrow of time. In physics, time's direction is often explained through entropy, the natural tendency of systems to move from order to disorder. A glass breaks but doesn't unbreak. Smoke rises but doesn't unrise. The universe expands. Stars die. Heat spreads. This, some say, is why time moves forward, not because of clocks, because of chaos. But the laws of physics are time-symmetric. The strange truth is that most physical laws, Newtonian mechanics, electromagnetism, even quantum equations, work the same backward as forward. They don't care about direction. It's only entropy and observation that give time a one-way street. If the universe began with low entropy, is that what makes time flow? Some believe consciousness creates the flow of time. In certain interpretations of quantum mechanics, reality doesn't fully happen until observed. If this is true, then your awareness, your act of witnessing, might play a role in how time unfolds. Are we not just in time, but shaping it? The block universe sees time as fixed. Some physicists propose that past, present, and future all exist simultaneously in a four-dimensional block of space-time. We feel the flow of time, but it's an illusion. All moments already are. You are not moving through time. You are in time, like a thread in a tapestry. Others see time as emergent, not fundamental. What if time doesn't exist at all, not in the way we think? What if it's an emergent property, something that appears only when matter, energy, and consciousness interact? In this view, time is like temperature, not a basic ingredient, but a side effect, a shadow cast by deeper laws. Could we ever send messages through time? Some researchers have explored the possibility of transmitting information rather than objects across time. Quantum entanglement, temporal interference patterns, and even theoretical tachyons, particles that only move faster than light, have been discussed. If we could send just one bit back, the implications would be infinite. Dreams, déjà vu, and temporal illusions. Have you ever dreamed of a moment and then seen it happen, or entered a room and felt you'd been there before? Neurologists explain these as memory glitches, fragments stored in the wrong order, but others wonder, are these echoes, glimpses from other branches of time? Time may not be the same for everyone. In cultures that live closer to the rhythms of nature, hunter-gatherers, nomads, islanders, time often feels circular, seasonal, or relational. In the modern world, it feels fast, scheduled, relentless. Time is not just physics, it is culture, feeling, and pace. Perhaps time does not pass. We do. One philosophical view is that time isn't a flow. We are. We move through a landscape of moments, just as we move through space. The past still exists. The future already does. We simply haven't reached it. Time is not running out. We are running along it. And finally, what lies beyond time? Every theory, every experiment, every dream we've explored still leaves us here, in this moment, a single point in the stream. Some believe consciousness itself exists beyond time, a state where before and after dissolve, where being simply is. No clocks, no waiting, just stillness, just now.